Okay, so in the last video you saw how to create template functions, and now we see how to create template classes or class templates. That is, we can also use this template prefix to generalize or templatize, or as we say in Java, genericize classes. So this template prefix can also apply to class definitions. All instances of this type T in the class definition are replaced by whatever parameter we choose to use. When we use classes, we do have to, besides the template class declaration, when we actually create an instance of the class, we have to use the angle bracket notation to say exactly what type we're going to use. Once the template is defined, we can declare objects of the class, and we've done this in Java with the vector class. Also, the vector class is available also in C++ in the standard library. So how do we set up a class? All we have to do is have the template prefix, and then just a regular class, only instead of regular types, we have type names, or the same type name that we have here. And remember, you're not restricted to just using T. It can be T, U, V, or any kind of string that's a valid identifier can be used here. And then you want to replace, rather, if you're intending to use that type elsewhere, that is, you're going to use something of type T elsewhere in your program, you have to put T everywhere. In this case, we have two data members. They are both of the same type T. One is called first. One data member is called first. The other one's second. So if we set up a pair of ints, we'll have basically two ints. If you have set up a pair of cars, we have two cars, first and second, and so on. With a constructor, we overload a constructor to initialize those two data members. Setter methods and getter methods for these two data members. Very simple template class. Okay, so if you look at the data members, you set them up the same way you would in a regular class, only you have to have the template prefix, and for the name of the class, you also have to specify this template parameter. And then the rest of it looks more like a regular function definition for a class, except that, of course, for type you have whatever identifier you used here, you have to use here as well. So, for example, here's the constructor, here's a setter method for the first. This also needs to have the class name with angle brackets and then the name of the identifier that you use for the type. Okay, so objects of this class can have a pair of values, both of the same type T. So you can have objects like score is a pair of ints, seats is a pair of characters, and then they're used like any other objects. So you can call methods, setter methods, or use get methods, and so on. So I have an example here in Eclipse. Here is our template class. There's the template prefix. Here's the class, just like in the notes. And then you can have the function definitions right here. That's what I chose to do. You can separate them out, but I think it's almost always better to put it all into one file and then pound include it where you're going to use it. Or in this case, all I did was I have it in the same place where I have my main. So that's not always the situation, but you can use this. So I have a default constructor, a constructor with two variables, setters and getters, and here they all are. Okay. And so how do we use it? We say name of the class, and then in angle brackets the name of the type that you want to store, and then an appropriate type for arguments to the constructor. Similarly, I have a pair of ints as well. I have an appropriate set of arguments. If I now change this to 10.1, well, that might probably work because C has automatic type conversion. Let's see what happens. Instead of actually conforming to the int, I'm saying that I should have, so if you notice here, I say that this class is templatized to use ints, then the two parameters to the constructor should both be of type int. But I'm trying to break the rules. Let's see what will happen. I think the C++ automatic type conversion might kick in, but it does give you a warning. So I think it does work. Implicit conversion from double to int changes values from 10.12. So it says I'll do it, but you might get in trouble. Okay, so that's how you use a templatized or a template class. Pretty straightforward. That is, you have to have the angle bracket notation and you're good. Okay, so pair member, so this class, template class pair, the member function definitions, notice that each definition is itself a template. So you have a template prefix before each definition. The class name before the scope resolution operator looks like this. Not only do you have the usual class name, plus you have the angle brackets with the template parameter. And it's not just the pair or class name. But the constructor name is just the pair. So you don't have to say pair angle brackets t colon scope resolution and then pair for the constructor name and then another angle brackets t. No. Constructor name is just the name of the class. You don't have there's nothing there with the angle bracket stuff. Destructor name is also tilde and the name of the class. Class templates can appear as parameters. So for example, here you have a standalone function, let's say, which takes as an argument a template class with a specific template. So here you're going to use a pair of ints, actually a reference to a pair class of ints. The type int is supplied to be used for the t variable in defining this class type parameter. And just so happens it was also called by reference, so it doesn't have to be. It just so happens. Okay, so template types can be used anywhere that standard types can be used. Can be used as function parameters, return values, any of those places. So rather than defining a new overload for something like this, you can also, so let's say you have add up as you have over here for pairs of ints. Let's say now you also want add up for pairs of doubles or add up for pairs of floats or cars or even a pair of pairs. Let's not get into that, but you can do that. You can have a pair of ints, but let's not do that right now. It gets a little bit complicated. So rather than overloading this add up function for many different types, you can templatize it by making it have a template prefix, returning something of type t that matches this, and then here's the thing is you say, well, this pair can be of any type. I'm going to make it a const, that is meaning that I'm not going to change it inside this function, and it's going to be a reference for efficiency. Okay, so all things we've done before. The new thing is that we're making a variable, one of the arguments is going to be actually a templatized argument. Okay, so function now, this function add up now applies to all kinds of pairs of things. It's very powerful. Restrictions on the type parameter. Only reasonable types can be substituted for t. Some of the things to consider are the assignment operator must be well behaved. Copy constructor must also work if you want to get things to work properly. If t involves pointers, then the destructor must be the correct type. You have to worry about all these things when you design a class template. Okay, so we can have we can define this new class type name by using typedef. You say typedef parent and give it an alias pair of ints, and do the same thing for type def pair angle brackets car and say call that pair of cars, and then you can use it just like any other class. You can say pair of int p1 pair 1 pair 2 and so on. So each one of these are of type pair angle bracket int. It's sometimes convenient just so that you don't see this fancy angle bracket notation. Sometimes it's useful to show that it is a template class. You can also use friend functions with template classes, same as ordinary classes, and so not much to say there. We simply require the type parameter where appropriate. And it's common to have friends of template classes, especially for operator overloads. There are predefined template classes we've used, and we used the vector class. This is a templatized class. There's tons of other ones. String is a subclass or a derived class of basic string angle brackets car. This works for car. You can also have basic string angle brackets double. That's a string of doubles. Anytime you have to do string operations, you can use car doubles. And let's say you have your own special class of something, you can use that with the built-in basic string templatized class. Okay, so as we said, string is just a subclass of basic string. It's an alternate name for basic string angle bracket car. It's just a type def basically. All member functions behave similarly for this basic string, whatever type you put in. And it's all defined in the string library. Inheritance, is actually nothing much new to say here. Derived template classes can derive from template or non-template classes, and then derived classes then naturally a template class. Syntax is same as ordinary class, that's derived from some other base class. Okay, so that's about it. Apart from the funny syntax, templates, remember the template prefix goes everywhere. Also, the other thing to remember is that when you set up, this is the most common mistake that I see, is when you set up the member functions, you do have to say class name, angle brackets, and then the whatever identifier you use here, and the template prefix, and then everything else is the same as regular. So apart from that, I think templates are pretty straightforward to use. The one other thing I would say is you can put all of this stuff that is outside main, the class declaration, the definitions of functions, into a .cpp file that doesn't compile separately. You can just pound include it into wherever you're going to use it. Like if you were using it here, you put it in a .cpp file, pound include the .cpp file, which is different, and then it gets compiled along with main. So there's some tiny things to worry about, but apart from that, it's pretty straightforward to use. So let me know if you have problems.